JavaScript, and that is going to be promises. A lot of people find these confusing, but honestly, I think they can be pretty simple if you understand them in the right way. What exactly is a promise? Well, a promise is simply an object that is going to have one of three states. So we can write.
Hi there, my front-end friends.
Write this here, we can say possible states are going to be pending, and then we can also have a fulfilled or rejected state. So we can say fulfilled or rejected. So what does this mean? It means that in a pending state, we don't know what's going to happen, right? Think about like a coin flip. We know we're going to flip the coin, but we don't know if we understand them in the right way. What exactly is a promise? Well, a promise is simply an object that is going to have one of three states. So we can write this here, we can say possible states are going to be pending, and then we can also have a fulfilled or rejected state. So we can say fulfilled or rejected. So what does this mean? It means that in a pending state, we don't know what's going to happen, right? Think about like a coin flip. We know we're going to flip the coin, but we don't know if it's heads or tails. And fulfilled means we know what happened. It was either heads or tails. And rejected means something went wrong, right? We don't know what happened. And these are useful in a lot of different circumstances, but one of the most common is going to be network requests, right? Say we send some request off to some server to get some information. That's going to be pending while we wait. And then when it gives us that information back, it becomes fulfilled. But if something goes wrong in that process, which oftentimes can happen, it's going to be rejected, and we need to handle this rejection, meaning we need to handle this error case. Okay, so how do you create a promise? Well, there's a few different ways, but the most basic is using the promise constructor. So let's say const promise is going to be equal to a new promise. Now, the promise constructor is going to take in a function, and this function is going to have two parameters, resolve and reject. Of course, we can call these whatever we want, but typically we use resolve and reject, or sometimes you'll see res for resolve and rej for reject. And that is how we create a promise. And we can come down here and say console.log out our promise, run this code, and you can see we have a promise with a state of pending. But then we can use these two functions to resolve and reject the promise. So resolve means to fulfill it. So these are sort of terms we use interchangeably, and reject, of course, means to reject it. So we could come over here and say resolve, and then we pass in whatever value we want to resolve to, say the value of 10. Now if I run this, you'll see we have a promise with a value of 10. We could put any value here, so this could be a string like hello world, and now we would have a promise.
Hello, hello. How's everyone doing today?
promise with a value of the string of hello world. Additionally, we can reject the promise. So we could say reject, and typically we reject with a new error, but we could also just have some other value here, such as this string, and you'll see we have this promise rejected hello world, and then we also get an error message because we have an unhandled error. We did not catch the error from the rejected promise. And we will see how to handle this unhandled promise rejection in a moment, but for now, let's go back to our resolved promise with hello world. Now, what's important about these promises is they allow us to have this pending state, and we're oftentimes using them with these values that we don't know what they're going to be just yet. And to sort of simulate this, one way we can do this is using a set timeout. So I'm going to say set timeout, and what we're going to do is say in the timeout, we want to resolve to a value of 10. But let's do this after 1 second. So now we log out a pending promise. And the reason being, this is non-blocking code. So we don't wait for the resolve to happen before moving on. So what this means is that when we log out the promise, the second hasn't passed and the promise is still pending. However, if we did something like this, say a set timeout here, and then inside of this set timeout, log out the promise, and let's say do this after 2 seconds. You'll see after 2 seconds, we're going to get the promise with the value of 10 because it has had enough time to actually resolve. We could also log this out twice, so we could do something like console.log, our promise, run this, and you'll see we get the pending promise, and then after 2 seconds, we'll get the promise with the value of 10. Okay, but this doesn't really feel great. We have these timeouts, and we're just sort of hard-coding values, but we don't know always when exactly our promises are going to settle, meaning when are they going to change states from pending to either fulfilled or rejected. For example, with the network request, we don't know when that request is actually going to come back, so we can't just use a set timeout like this. So instead of this, what we can do is use some functions on the promise, because remember, promises are just objects. We created them with this constructor function. So we could say promise.then, and .then is going to take in a function. So this is going to get the value from the promise, and we can do whatever we want with it. So for example, we could say console.log out our value. And now what this is saying is take this promise, and whenever it finally resolves, then run this function that's going to log out the value. So now if I run this, you'll see after 1 second, we are going to get this value of 10. Now, one other note here that doesn't really directly have anything to do with promises, but I do think it's interesting, is that .then right now is taking in a callback function, and this function takes in a value, and it passes that value to console.log of the value. So this is actually essentially equivalent to we are going to get this value of 10. Now, one other note here that doesn't really directly have anything to do with promises, but I do think it's interesting, is that .then right now is taking in a callback function, and this function takes in a value, and it passes that value to console.log of the value. So this is actually essentially equivalent to just saying .then console.log, and this is going to work the same way because remember, console.log is itself a function, so we don't need this whole sort of wrapper of passing the value into it. But okay, now what do we do if the promise actually rejects? So if we said reject, and we had some error, so say new error, something, went wrong. If we run this, we're going to see this error shows up in our output because we didn't do anything with the error. We didn't catch that error. And there's a few ways we can do this, but one option is that .then could actually take in a second parameter. So we could add a second parameter, and this is going to get in that error. We could do something like console.log, oh no, and then let's concatenate the error message. So we can say plus error, run this, and you'll see now we get oh no, and then error something went wrong. And this is going to be that whole error object. So if we wanted, we could do error.message, and now we would get oh no, and then just something went wrong without this. Now we get oh no, and that error. We could do something something like console.log, oh no, and then let's concatenate the error message. So we can say plus error, run this, and you'll see now we get oh no, and then error something went wrong. And this is going to be that whole error object. So if we wanted, we could do error.message, and now we would get oh no, and then just something went wrong without that error semicolon piece. Now, this does work, but oftentimes this is actually not the syntax that most people prefer. So what I'm going to do is take this whole function, and I'm going to cut it from here. And what most people actually prefer is instead to do .catch after the .then, and then pass in this same function. And this is going to do essentially the exact same thing. So .catch works like .then, but it just takes in a single function, and it works like that second function that we could pass in to .then. So it's going to actually catch whatever errors we have, and it's going to allow you to do something with them. But how does this even work? So we have .then, which is a function of the promise, but what is .catch? It is a function of whatever .then returned. Well, it turns out that .then actually returns a promise. So because this returns a promise, we can actually use other functions of the promise on that promise. We can also chain multiple .thens. So let me show you what this looks like. So let's go like this. What we could do is say promise.then, and let's take the value, and let's say value times 2. So we're going to take our value and multiply it by 2. And let's change this back to resolve and 10. So what's going to happen? happen is in 1 second, we resolve to 10. And then we get into the .thens. And the first one takes a value and it multiplies the value by 2. So this means that this returns 20. And then it's going to be a promise because .then returns a promise with whatever value was returned in here. So because of that, we have a promise with 20. And that promise with 20 is already going to be fulfilled. So then we get into this function, this .then, and it's going to console.log out that value. So if we run this, you will see that we actually log out 20. And we can do this as many times as we want. So we could do .then value, and we could do something like value plus 5. So now what we're doing is multiplying by 2, which is 20, and then adding 5, so we will get 25. But now, if we did reject here instead, and let's put some error again, say new error, and I'll just put error message like this, run this, you'll see we get the oh no, and then the error message. So this promise, the first promise, rejected. So what happened is we got into this first .then, so we had a rejected promise and we called .then, and it has no second function. So all it does is it just returns the rejected promise we already have, and it goes down to this one. And this one, again, does nothing with it because it has no second.
Promise.
How are you guys doing? Are you having a fun, what is it, Friday? Oh boy, just stopped to work.
Function, so we return that rejected promise. Same thing here, we do nothing, so we have a rejected promise, and we get to the catch, which actually uses that rejected promise. Now, catch also returns a promise. So what we could do here is, let's actually open this up on a new line and go like this. And what we could do is say in the catch, return 100. And now what we could do is say below the catch dot then, and let's just do console.log. And now if I run this, you'll see we get oh no and the error message, and then we get 100 because the catch returned another promise, and that promise had a value of 100, and then this dot then logged out that value. Now, a few things to note here. One, this isn't a great example because we wouldn't really need all these dot thens for this. This is doing a lot of extra work that we don't need. Of course, we don't need to create all these promises just to multiply the value by 2 and 5. We also very rarely would return from a catch and then do something with that value again. It can happen, but it's not a pattern that's super useful. But the point here is to understand the pattern of taking a promise and being able to chain dot then and dot catch after it, and the fact that these are just going to keep returning new promises. Now, it's worth noting here that there is also one final function we could use here, and that is going to be dot finally. And this, again, takes in a function. This one is not going to have any parameters, and we can do whatever we want here. So for example, we could say console.log done, and if I run this, you will see we get done at the end, and this is going to happen regardless of if this promise rejected or resolved. So if we said resolve and let's do a value of 2, run this, you'll see we end up logging out 9 here, and then we actually log out undefined here because console.log returned undefined to us, so this value is now undefined, but then we log out done down here. And again, this undefined is because of the fact that we had this dot then that is doing a console log, and that has no return value. If instead we did value and then say something like this, and we did console.log the value, and then actually return the value, now you'll see we get 9 a second time down here. But then regardless of what happens, we always are going to get into this finally block. Okay, so now a few other things I wanted to show with promises. So let's remove all of that. And first of all, it's the fact that we can create a promise that's actually not pending. So what I could do is I could say const promise is going to be equal to promise.resolve and say 10, and then we could do console.log out our promise, and if we run this, you'll see we get a promise with 10. So promise.resolve, you'll notice we don't use the new keyword here, we just call this function and it gives us a resolved promise, and that promise of course is fulfilled. We could do reject as well, and this is going to give us a rejected promise, so you can see we have a promise that was rejected with the value of 10. Now on this promise object, we also have a few few other pretty useful functions. The first is going to be promise.all. What promise.all does is it takes in an array of promises. So let's say promise.resolve, and let's say 10, and then we'll do, oops, we need a comma there, promise.resolve, and let's say 100 here. And now what we can do is, let's save this value. Let's say const all is going to be equal to that. Let's say console.log out all. And what you'll see we get is this pending promise. But if we would come over here and we did all.then and then console.log, so we wait for this to resolve, what we're going to get is an array with those values. So essentially what this is going to do is it's going to wait for all of these promises that we pass in to be resolved, and then it's going to return an array of their values. And now again, remember promise.all returns a promise, and it's taking in promises. So what we can do is we can give it promises that are not immediately going to resolve, and it's going to actually wait for them. So for example, instead of this one here, what we could do is say new promise, and let's pass in a function with resolve and reject. And what I'm going to say is set timeout. And inside of set timeout, we will resolve to the value of 10, but we're not going to do it for 1 second. And now what's going to happen is when I run this, it's going to take a second before promise.all actually calls.then. And when it does, we will have those values of 10 and 100. Now, what is important here is if one of the promises rejects, so let's say promise.reject, we are going to immediately reject. So this is not going to wait for this promise. It is simply going to reject the second it finds one of these promises are rejected. Now, if you don't want this, you can change it to all settled, and this is going to wait for all of the promises to settle, meaning switch from pending to fulfilled or rejected, regardless of if they are fulfilled or rejected. So even if they reject, it's still going to wait for all of them. You can see if we run this, we get these objects with the status of fulfilled and rejected, and the value for 10, and the reason was 100, so that's what we actually rejected with, which typically would be an error value, but we have 100 here. Now we also have another function here that's going to be race, and race does not care if they fulfill or reject. What it cares about is which one settles first, meaning which one actually resolves or rejects first. And in this case, we have promise.reject 100 happens effectively immediately, and then we have this one that takes 1 second. So what we're going to actually get is the rejected value. So we have this unhandled promise rejection again, but if this was resolve and we run this, you'll see we get 100, and it doesn't even care about this one. Even if we rejected this, you'll see it doesn't matter because of the fact that race is just going to return the first one, and the first one was 100, which was this resolved promise. However, sometimes what you want is you want the first resolved promise. You want to ignore the ones that have errors and just get the first one that resolves, so the first one that actually becomes fulfilled. And for that, we can use any. So for example, here, let's say we reject this one and we resolve this one, but it takes a second. So even though it takes a second, it's going to actually wait for this one because this one rejected. Now, of course, if we reject everything, then there's no result here. And this is actually going to throw an error. So you can see we have trigger uncaught exception. And it's worth noting here that this is not this error. So we don't actually see this value of 10 anywhere. What it's doing is it's simply throwing an error that, hey, you called promise.any, but every single promise that you passed into this array actually rejected. Now, this promise object does have a few other functions that are a little bit newer, so we don't see them used a ton yet. And what I'm going to paste in here is some code that is a pretty common sort of pattern that we used to see a lot with promises. And that was creating a new promise and having resolve and reject, but needing those resolve and reject functions outside of this scope. And the way to do that was simply to create these global variables and to put these values in those global variables. However, there is now a new way to do this. So what we can do is we could say const, and we will have our promise, we will have our resolve, and we will have our reject. And we are going to destructure these from a call to promise.withResolvers. And this is going to show some errors because we have the same variable names. But if we get rid of that, you'll see we now have this promise from promise.withResolvers. So we have the promise, resolve, and reject. If we come down here and we say console.log our promise, you'll see it is a pending promise. If we did something like resolve to 10 and then do console.log of the promise again, we now have a promise with a value of 10. That's worth noting. Resolve and reject. If we come down here and we say console.log our promise, you'll see it is a pending promise. If we did something like resolve to 10 and then do console.log of the promise again, we now have a promise with a value of 10. That's worth noting that this doesn't have amazing support across browsers just yet, but depending on when you're watching this, it might be more or less usable. And this isn't something you'll want. Want to use a ton, but if you ever do find yourself needing the resolve and reject functions at a larger scope than inside of the promise callback, then you can do it with the resolvers, and I think it's just a bit cleaner syntax. But now, thinking of cleaner syntax, we saw that big dot then and catch chain, but that's actually not the only way to handle promises. It is the original way, but there's a new way that you've possibly seen before, and that's going to be with async and await. Okay, so let's get rid of this, and we don't need this either, but we can leave our new promise here, and let's say our promise is going to resolve in a set timeout. So after, say, 500 milliseconds, we will resolve to, say, 100. And we saw before that we could do something like promise.then and then do something with it. So we could do something 500 milliseconds, we will resolve to, say, 100. And we saw before that we could do something like promise.then and then do something with it. So we could do something like console.log. And this, again, works. But now there is another way to do this, and that's going to be using async and await. So these are two keywords that are used connectively a lot. So async allows us to create asynchronous functions. So what I mean by that is we can say async, and then we can just define a function like we normally would. So let's say function and give it some name. So let's say log promise. And now this function works just like any other function. So I could say in here console.log, and let's just log out number 5 just to show you that I can say log promise. I can just call this like a function and it logs out 5. So it works just like any other function. But what does async actually do? Well, async says this function is asynchronous, therefore it should return a promise. So if we were to come down here and we said const result equals log promise, and we call this, and then we console.log number 5, just to show you that I can say log promise. I can just call this like a function promise. And now this function works just like any other function. So I could say in here console.log, and let's just log out number 5, just to show you that I can say log promise. I can just call this like a function and it logs out 5. So it works just like any other function. But what does async actually do? Well, async says this function is asynchronous, therefore it should return a promise. So if we were to come down here and we said const result equals log promise, and we call this, and then we console.log our result, what you'll see is we log out 5 because that's what happens in function, and then our result is this promise with the value of undefined because we returned nothing. But if say we return 1000, you'll see we have a promise of 1000. So essentially this just creates a promise with whatever value you return. But okay, how does this relate to our original promise and dot then? Well, what we can do is we can come back into log promise. What we can do is use the await keyword. So what we can say is say await, and we will await our promise. And this is going to be a value. So we can save this value. So let's say const result is equal to await of our promise. And then we could do console.log our result. And now let's call log promise again. So let's say log promise, call this, and you'll see it's going to log out 100. So it's waiting for this 500 milliseconds. So this code actually waits. And then once result is a resolved promise, then we are going to actually log it out. And now you might be saying, okay, but why do we even need async here? We can just do this, right? We don't need this because we're not using the fact that this is now implicitly returning a promise. However, this is actually something we do need. So if I remove that, you'll see we get this is underlined and says await expressions are only allowed within async functions. So if we run this, you'll see we get that same error, syntax error. Await is only valid in async functions and at the top level bodies of modules. So inside of asynchronous functions or inside of the top level of a module is the only time that we can use the await keyword. We cannot use it in a standard function. Okay, but now what if this function... Now, you might be saying, okay, but why do we even need async here? We can just do this, right? We don't need this because we're not using the fact that this is now implicitly returning a promise. However, this is actually something we do need. So if I remove that, you'll see we get this is underlined and says await expressions are only allowed within async functions. So if we run this, you'll see we get that same error, syntax error. Await is only valid in async functions and at the top level bodies of modules. So inside of asynchronous functions or inside of the top level of a module is the only time that we can use the await keyword. We cannot use it in a standard function. Okay, but now what if this function rejects? So if we do reject and let's do a new error and we'll just say hello world and we run this, you'll see we have this error from where we rejected, but we don't have like the equivalent of catch. So how do we catch the error? Well, there's a few things we could do. One option is log promise does return a promise. So we could say .catch and maybe we take the error and do console.log and we could do oh no plus the error dot message. Run this and you'll see we get oh no hello world. So log promise, because this through an error is going to throw an error, we never end up getting to console log result. And since this errored out, the promise is rejected and we get into this catch. However, I don't personally love this because we're sort of combining the then chain methods of .catch with async and await. I don't think that's the best way to do things. So what I'm going to do is remove that. And instead what we can do is use try catch. So we can say try, and inside of our try block, we could run this code. And then if we catch an error, so we can say catch our error, then what we're going to do is do that console log again. So we can say console log oh no plus our error, and you'll see this is going to work the same way. So oh no, and then we have the error, or we could do error.message if we want. We'll have oh no, and then hello world. But of course, if we go back to resolving here and say 100, you'll see we get 100 because in the try block, we don't throw an error. And that's essentially all there really is to promises. I know it can seem sort of confusing because it's a lot of syntax. You might have not used the syntax very much before, but if you just think about them in this core idea of all a promise is an object with one of three states, pending, fulfilled, or rejected. And when that state changes, potentially we might want to do something. So when that state goes from pending to fulfilled, we might want to say do something with that value at fulfilled to, or when it rejects, we might want to catch that error and do something with that. When you think about it in this way, it's pretty simple from a sort of conceptual perspective, and then it just comes down to remembering the syntax of either using async and await or using that dot then and catch chain. And of course, promises are something that gets used a lot in JavaScript, but if you want to see some features that I don't see many people actually using, you should watch this video next.
Promises are an important feature of JavaScript, but they can be a little hard to wrap your head around. So today I have Chris Ferdinandi with me to help break everything down, because as well as I know CSS, he knows JavaScript. So thanks for joining me today, Chris.
Kevin, thanks so much for having me. I'm glad to be here. Promises are weird, so I'm excited to talk about this one.
I'm looking forward to unraveling them for us.
Synchronous, historically, most of JavaScript has been synchronous and single-threaded, which means that things happen one at a time, and you can't have two tasks kind of going on concurrently. A lot of modern JavaScript code tends to be asynchronous by default, but that was not always the case. And for most asynchronous code, the way that's working under the hood is with promises. And so a promise, as its name implies, is a promise that something will happen in the future, is the way I like to think about it. You're not, as a developer, you're not often creating promises directly. You can, and there are absolutely times where people do that. So if you have a library that is not asynchronous by default and you want to make it asynchronous, you can use the promise object to create your own and kind of make it that way. But that's another video for another time. But understanding how promises work can help you understand how most of the asynchronous stuff in JavaScript works and how you work with it. We're going to create a promise from scratch just to kind of understand what's going on. So I'm using the new promise constructor to do that. I'm assigning it to this say hello variable. But inside my promise, I pass in a callback function. And that callback function accepts a couple.
Full time. I forget the relief that you get when you're, when it's Friday night and you get to go out or whatever. It is indeed cold. Boy, the stop to work full time. I forget the relief that you get when you're, when it's Friday night and you get to go out or whatever. It is indeed cold. I'm back home. And boy, is it cold. Tell us about the AI India Summit. Oh, don't have enough context. I just know someone from their team reached out and echo aa rahi hai. Can you guys hear me well? Hello, hello, hello. Can you guys hear me well? Hello, hello, hello. All right. Today we'll be only covering promises. Yes. What was I saying? It's just happening in our campus, but I don't have any idea or too much context. I think it's like a bunch of AI people, like smart AI people who are, meeting. I think it's more of a meetup, less of a talk situation, but I'm unsure. All right. Exam is coming on 15th of February. There are no updates. It's going to be a little bit of a surprise. Maybe you guys will GPT if you're prepared. What about the Solana dip is a beautiful question. Where is it now? Has it reached 60 already? I don't know, man. When it was at 200, I told my friend to max buy. And then thankfully he didn't. And now it's at 84 now. Now I've told him not to max buy. So, my good investor instincts are kicking in. And as always, I'm going to sell low and then eventually buy high. All right. What's the referral process in which niche getting more placed? Let me see. I mean, I can give you a rough idea. Mostly it's full stack, very honestly. For us, it's full stack in Web3. Some Gen AI companies. But if I look at the Super30 placement stocks, let's start from the top. Full stack company, mobile engineer in a full stack company, Gen AI company, full stack company, little bit of AI, full stack company, crypto company, full stack company, crypto company, full stack, weird, not full stack like IoT, but full stack company, crypto company, full stack, Raj, this is full stack, Rush Tanej, it's like crypto. Pavitra Ki was full stack. This is crypto. Again. IoT full stack. Shikesh is, I think, like any kind of like slightly AI mode, like a lot of companies that's doing heavily something on top of APIs. A lot of people in crypto companies also doing, non-crypto stuff, mobile engineering, front engineering. Some very specific Solana roles of, mostly indexing, some DeFi, some what does Dhruv do, like hedge fund stuff, validator stuff. 3 people went there. So basically, if you're optimizing for probability, probably optimize for full stack. That data specific Solana roles of mostly indexing, some DeFi, some what does Dhruv do, like hedge fund stuff, validator stuff. 3 people went there. So basically, if you're optimizing for probability, probably optimize for full stack stuff, validator stuff. 3 people went there. So basically, if you're optimizing for probability, probably optimize for full stack. That's where you need engineers, right? Like today, even smart contracts are very easy to write. I was talking to someone yesterday who works like consulting jobs for 2-3 crypto companies. He consults as a smart contract engineer, and he said most of my job is now AI. And thankfully I'm I have a position in Solana, which is why people pay me this much, but they probably shouldn't. So I would still say, full stack is the most, the place you need a lot of engineers. Why? Because that's the thing that's changing very quickly compared to, AI research, ho gaya, smart contract writing, ho gaya. In these two places, you don't need a lot of engineering expertise because you have to do it once. And, release cycles are really long. 2 साल में एक बार कोई नया improvement आएगा to Solana validator, or, there'll be a better model. But other than that, the thousands of companies are built on top of this base layer. Is there a lot of hiring happens? I would optimize for that. With that, we kick things off today is promises. I will start off with a question and then we will proceed. The question is going to be, how many of us already know this? This is going to be a mostly difficult class, never an easy topic, especially for complete beginners. A lot of times skipped and gotten into later, but hum shuru mein kar lete hain. How many of us already know what are promises, what are async functions, maybe what are first callbacks, but you don't need to know that. Mostly promises. Beautiful. The ratio here is much better than the ratio in the Web3 cohort. 50% already know this. I have made one assignment for you. Mikey, can you post the yesterday's Super30 assignment here so people can do that? Mikey will post that in the chat. Mike, if you're here, please post yesterday's full stack assignment, Super30 assignment here. So the people who do know promises can probably just focus there. For the people who don't, let's kick things off. It's not an easy concept. Starting from classes and then diving into what are promises. So we'll go slow and hopefully, I'll only optimize for the last 50% now. I think 50% already know this. So for the other 50%, let's understand what is asynchronous programming. We understood a little bit of this last week. What are classes in JavaScript, which has nothing to do with asynchronous programming. It's just a general concept that's used in not just JavaScript, it's used in Java. It's used in many other object-oriented languages. It's also a concept in JavaScript. So we're going to start with that. Barring asynchronous on the side, asynchronous ko side pe rakh ke, one slightly simpler concept to learn is classes in JavaScript. There are many primitive types in JavaScript. We've understood a few of these. Let me open a fresh folder here. This one right here. Let me write some basic JavaScript code that hopefully all of us understand by now. Let me delete this file. I have an index.js file inside which I can write, a bunch of code. For example, I might write something like this. Let a equal to 1, let b equal to 2, function sum a comma b, return a plus b, and then I can console.log sum of whatever, a comma b here, or I can just do this. Hopefully this is very easy to digest what I'm doing over here. If I run node index.js, the code will execute and print what on the screen? It will print 3 on the screen. I can also write this code like this. Let answer equal to this and then log just the answer variable. Or I can do the other thing, which is simply write console.log of sum of 1, 2. This is code that we understand. Here we're using primitives like integers. We're using primitives like integers. Integers are numbers, or even decimal point numbers are fine, but either way. These are numbers in JavaScript. We understand them. We understand strings, we understand booleans. These are the simple primitive types in JavaScript. There are also complex types in JavaScript like objects and arrays. Hopefully you remember these from the existing classes. What is an object? Something that looks like this. Let user equal to name Harkirat age 21. And then if I log user.name, what gets printed on the screen is Harkirat. If I log user.age, what gets printed on the screen is 21. That is one thing. The other thing is an array that looks something like this. Let array equal to 1, 2, 3, 4, 5. And then I can write some code. There are common DSA questions you might have heard of. For example, find the maximum value in this array, find minimum value, find the second minimum value, so on and so forth. Hopefully these are DSA questions you've already done. You understand what an array is, what an object is. There are also more complex types like an array of object or object with arrays. For example, let user equal to name Harkirat, age 21, and then my addresses can be an array, or the cities that I live in can be an array. I live in Delhi, Chandigarh, and whatever, Mumbai, let's say. So here we have an object where one of the values of these keys prints Delhi on the screen over here. For people who are looking for a challenge, actually, here is a small side quest. Try coding the promise class yourself. Code the promise class yourself. This is like a good challenging problem to do. You also have the Super30 assignment. You can also try to code this. For everyone else, we understand primitive types. Let's understand a slightly more complex type called classes in JavaScript. Not a JavaScript specific concept used in many other languages. Classes in JavaScript or otherwise are a way to define a blueprint for creating objects. But when I say objects here, I don't mean these objects. When I say objects here, I don't mean these objects. ये एक different type of objects होते हैं. When you create classes, then also you create objects. These are different type of objects. They let you define blueprint for creating objects. Matlab, what if I want to create something like I want to build something like Flappy Bird. What does the Flappy Bird game look like? In the Flappy Bird game, there is a bird over here, and then there are a bunch of rectangles that come right in the way. There are a bunch of rectangles that come on the way, and you have to navigate through these rectangles. That is how the Flappy Bird game is written. Each one of these rectangles, if you look at it, has like a x, the x location it is at, for example, it might be at x equal to 300, has a height, for example, the height of and has probably another variable कि ऊपर सटा हुआ है कि नीचे सटा हुआ है. Is it at the
So this section is about object-oriented programming, and this lecture is going to be a very general, high-level overview of this programming paradigm. So we're going to talk about what object-oriented programming is, how it works in general, and about its 4 fundamental principles. So this is going to be a really important and valuable lecture, and so let's get started. So welcome back to the second part of the introduction to object-oriented programming. And in this lecture, we will learn about OOP specifically in JavaScript. So how it's different from the more traditional OOP, and also different ways of implementing this paradigm in JavaScript. And don't worry, this will be a lot shorter than the last lecture. So
the top, or is it at the bottom? So is at the top?
just to review, in the last lecture, we talked about the classical object-oriented programming model with classes and instances created from these classes.
But the width is
And remember, a class is like a blueprint, which is a theoretical plan, and that we use to build many houses in the real world. And in the same way, the theoretical class can be used to create actual objects, which are called instances, and which we can then use in our code. In this process,
rectangle with a width of 20.
many people also just use this terminology in the context
For this
of
rectangle,
JavaScript.
X is a
And
little
finally,
more, it's not
JavaScript syntax itself
500.
uses also
Height is a
some of
little
these
less,
terms,
so height is not
for example,
400.
instances. And so you really need to know what a class is and what an instance is. Now, anyway, how does OOP actually work in JavaScript? Well, in JavaScript, we have something called prototypes. And all objects in JavaScript are linked to a certain prototype object. So we say that each object has a prototype. And now here comes the magic. So the prototype object contains methods and properties that all the objects that are linked to that prototype can access and use. And this behavior is usually called prototypal inheritance. So again, prototypal inheritance means that all objects that are linked to a certain prototype object can use the methods and properties that are defined on that prototype. So basically, objects inherit methods and properties from the prototype, which is the reason why this mechanism is called prototypal inheritance. Just note that this inheritance is actually different from the inheritance that we talked about in the last lecture. So that was one class inheriting from another class. But in this case, it's basically an instance inheriting from a class. So that's very different, and so keep that in mind. Or maybe in your notes, all right? Now, we can also say that objects delegate behavior to the linked prototype object. And behavior is just another term for methods here. So besides prototypal inheritance, we also call this mechanism delegation. And that's also the reason why this arrow is pointing upwards, because technically, objects delegate their behavior to the prototype. On the other hand, in classical OOP with classes, the behavior, so the methods, are actually copied from the class to the objects. And so that is completely different. Now, I don't want you to stress out about the exact terminology here, okay? So I know that this is a lot of new stuff to take in, so a lot of new words and new concepts. But this is just to paint a very clear picture and to give you the complete overview. What matters to me is that you understand how this prototype inheritance actually works. Because when we actually start using this in practice in the next lecture, it won't really matter if it's called inheritance or delegation, as long as it just works as intended, right? But since you came to this course to learn how things actually work in JavaScript, I'm giving you all that information here. Even though for now, it looks a little bit too much, but I'm sure you will find it useful eventually. So actually, we will come back to this diagram and fill it with some more detail after we have actually implemented prototypes in JavaScript. So after you have actually see how they work in practice. And by then, I'm sure that all this will make 100% sense to you. But anyway, we have actually already seen this mechanism in action many times before, but without knowing that it was happening. For example, each time that we use an array method like map, we are able to use that method because of prototypal inheritance. So when you go to MDN to check the documentation for any array method, what you will see there is that it's actually called array.prototype.map. But why is that relevant? So what does this mean? Well, array.prototype is the prototype object of all the arrays that we create in JavaScript. So just like this example array called num here. Now this prototype object contains all the array methods, including map. So this is where they are actually defined. So since array.prototype is the prototype of the num array, it means that num is linked to that prototype. And therefore, it has access to all the methods that are defined on the array.prototype object, just like the map method. So in a sense, our array inherits the map method. Or again, we can also say that the array delegated the behavior of mapping to its prototype. So you can choose whatever makes more sense in your mind. But what matters is that the map method is actually not defined on the num array itself, but on its prototype. And of course, we're going to check out this behavior also in our code in practice. Okay? Now, right now, you might have a ton of questions in your head. Like, how do we actually create prototypes? And how do we link objects to prototypes? And how can we create new objects without having classes from which we can instantiate objects? So, in summary, the question is, how do we implement object-oriented programming in JavaScript in practice? Well, in JavaScript, there are actually 3 different ways of doing all this. The constructor function technique, ES6 classes, and also the object.create function. So first, constructor functions are a way of creating objects programmatically using a function, which will also set the new object's prototype. And this is actually how built-in objects like arrays or maps or sets are implemented. Also, this is how OOP has been done in JavaScript, basically since the beginning. Next, the ES6 release introduced classes into JavaScript. And so now, ES6 classes are actually the more modern way of doing OOP in JavaScript. However, keep in mind that these are actually not the kind of classes that we talked about in the last lecture and in the last slide. They are, instead, just so-called synthetic sugar over constructor functions. So this means that ES6 classes are basically just a layer of abstraction over constructor functions. So it's really just a nicer syntax that makes it easier for newcomers to do OOP in JavaScript. But behind the scenes, ES6 classes are actually implemented with constructor functions, and so they also use prototypal inheritance, just like we learned in the last slide. Finally, there's also the object.create function, which is basically the easiest and most straightforward way of linking an object to a prototype object. However, it's not as used as the other 2 methods, as we will see over the next couple of lectures. Now, to finish, one important thing to keep in mind is that the 4 principles of object-oriented programming that we learned in the last lecture, so that's abstraction, encapsulation, inheritance, and polymorphism, are still valid and important with prototypal inheritance. And throughout this section, we will of course learn how to use and implement these principles. All right, and with all that being said, let's now finally put OOP into practice and get a bit more technical. Let's finally implement object-oriented programming now, and starting with constructor functions. And as always, I already have the starter files open here in my VS Code editor. So please go ahead and do the same now, and we can actually already also open up a new terminal and start our live server. So we can close that, open up the console here, increase it a little bit. And now we're all set up and ready to go. So we actually kind of used object-oriented programming before, but in a very limited way, because we had no way of programmatically creating objects. And so all we did was to use some simple object literals, for example, in the Bankist app, right? But now that all changes with constructor functions. So we can use constructor functions to build an object using a function. Now, a constructor function is actually a completely normal function. The only difference between a regular function and a function that we call constructor function is that we call a constructor function with the new operator. But enough talk, let's now actually create a constructor function for a person. So that's person, and in OOP there is this convention that constructor functions always start with a capital letter. And so we should always follow that convention too. And in fact, other built-in constructors like array or map follow that convention as well. Now here I'm using a function expression, but of course a function declaration will also work. Now an arrow function will actually not work as a function constructor, and that's because it doesn't have its own this keyword, and we need that. Okay, so only function declarations and function expressions. Now remember that this function is basically going to produce an object, and in this case for a person. So we want the person to have a name, or let's say a first name, and a birth year. And so we specified these 2 parameters for that here in our constructor function, so that we can then pass in the name and the birth year. And now let's actually call this function. And so, as I said previously, the only difference between a regular function and a constructor function is that we call the constructor using the new keyword. So we write new, then person, and then let's pass in Jonas and 1991, let's say. So this new operator here is actually a very special operator, because what it does is to call this function here, so this person function, but it does a whole lot more than just that. So let's see what exactly happens when we call a function with the new operator like this. So behind the scenes, there happen 4 steps. And let me actually write them here, because this is very important. So first, a new empty object is created. So an empty object is created. Then, afterwards, the function is called, and in this function call, the this keyword will be set to this newly created object. All right, so let's write it here. So the this keyword is this new empty object. So basically, in the execution context of the person function, the this keyword will point to this new object here that was created in step number 1. And remember, all of this happens only because we are calling the function using the new operator here. So step number 3 is that this newly created object is linked to a prototype. So linked to prototype, but more about this in the next video. For now, we just care about creating the object itself. Finally, the last step is that the object that was created in the beginning is then automatically returned from the constructor function. So the function automatically returns that empty object from the beginning. But actually, at this point, the object no longer needs to be empty. And this is actually the trick of making the constructor function work. So let's go here now and log to the console the this keyword. And so we already know that it should be this empty object that was just created here in step number 1, right? Because the this keyword inside this function will be exactly that empty object. And again, that's because we are calling it with the new keyword. So let's see. And indeed, we get this empty object. And the browser console is actually already telling us that it's basically here of the type person. All right? And so this is just the name of the constructor function. All right. And now let's use this knowledge to our advantage, because we already know that in the end of this function, the this keyword will basically be returned. And so whatever we add to that empty object will then be returned from the function. And that returned object is going to be the object that we are trying to build here, actually. So all we need to do is to now take that first name parameter, so the value that we receive, and then create a property on the this keyword with the same name, and then set it to that value. And then the same with the birth year equal to birth year. And so now let's store the result here in some variable, and that's actually it. So let's see what Jonas is going to look like. Now we have to log it to the console here. If you want to take a look at it. And indeed, here it is. Here is the person object with the first name Jonas and the birth year that we passed here into the constructor function. So let's quickly recap what just happened here. So again, we're calling this constructor function with the new keyword, or the new operator. And so therefore, a new empty object is created right away. Then the function is called, and in here the this keyword is that empty object. And then in the function, we start to set properties to that object. And we give them the exact same name as the parameters that we're passing in here. And of course, they could have any other name, so it doesn't have to be the same name as our arguments. So it doesn't have to be the same name as our parameters, but this is kind of a convention. So if we pass in first name, then we should also create a property called first name. So then here, by the end of the function, or this keyword now has these two new properties. And then here in step number 4, that object that was created in the beginning is then automatically returned from the function. And so at this point, that is the object with these two properties. And so that's going to be the result of this function call, and so it will then be stored in Jonas, and then that's what we get here. Great. So I hope that made sense. And so now, of course, we can use this constructor function to create as many different objects as we want. So let's say we want to create Matilda, using 17, and let's just do another one. Why not? Let's call it Jack, new person, just so you see that we can create as many objects now based on this constructor function. And so this is a bit like the analogy from before, where this constructor function is now the blueprint for a house, and then each of these objects that we create through that function, so through that blueprint, will be the actual house in the real world. So in this case, the actual objects with actual data in them. So Matilda and Jack, and so of course, now each of them is its own new object that we created programmatically using a function constructor. Now remember from one of the previous lectures that in classical object-oriented programming, an object created from a class is called an instance, right? Now, we didn't technically create a class here, because as we discussed before, JavaScript doesn't really have classes in the sense of traditional OOP. However, we did create an object from a constructor function, and actually 3 objects, right? And constructor functions have been used since the beginning of JavaScript to kind of simulate classes. And so therefore, we can still say that Jonas here is an instance of person, and the same goes for Matilda and for Jack here. And constructor functions have been used since the beginning of JavaScript to kind of simulate classes. And so therefore, we can still say that Jonas here is an instance of person, and the same goes for Matilda and for Jack here. And in fact, there is even the same goes for Matilda since the beginning of JavaScript to kind of simulate classes. And so therefore, we can still say that Jonas here is an instance of person, and the same goes for Matilda and for Jack here. And in fact, there is even an operator that we can use to test for. We can still say that Jonas here is an instance of person, and the same goes for Matilda and for Jack here. And in fact, there is even an operator that we can use in the beginning of JavaScript to kind of simulate classes. And so therefore, we can still say that Jonas here is an instance of person, and the same goes for Matilda and for Jack here. And in fact, there is even simulate classes. And so therefore, we can still say that Jonas here is an instance of person, and the same goes for Matilda and for. So therefore, we can still say that Jonas here, just like this. Then if we do this, this should of course be false, right? Because of course we didn't create this variable here, so this object using any constructor function. All right. And since we're talking about instances here, we can also say that these properties here will be the instance properties. Let's write that here. And that's because the properties first name and birth year will be available on all the instances that are created through this constructor function. So that's for properties. But now what about methods? So what if we wanted to add a method to our objects? Well, just like we added properties, we can of course also add methods. So let's again use our old friend called age here. And so here we are going to create a function and assign it to this property. And so this will then basically become a method, right? And this here should simply log to the console 2037, which is the year we've always been using, and then minus this dot birth year. And so this method is exactly the same that we've been using all the time, right? So this would work just fine here, but this is actually a really bad practice. So you should never do this. You should never create a method inside of a constructor function. That's because imagine we were going to create 100 or thousands or even tens of thousands of person objects using this constructor function. Then what would happen is that each of these objects would carry around this function here. So if we had 1,000 objects, we would essentially create 1,000 copies of this function. And so that would be terrible for the performance of our code. Again, don't do this. But instead, to solve this problem, we are going to use prototypes and prototype inheritance, just like we discussed in the last video. All right, great. So this is the basics of constructor functions. Just note that function constructors are not really a feature of the JavaScript language. Instead, they are simply a pattern that has been developed by other developers. Essentially create 1,000 copies of this function. And so that would be terrible for the performance of our code. Again, don't do this. But instead, to solve this problem, we are going to use prototypes and prototype inheritance, just like we discussed in the last video. All right, great. So this is the basics of constructor functions. Just note that function constructors are not really a feature of the JavaScript language. Instead, they are simply a pattern that has been developed by other developers, and now everyone simply uses this. And this now includes you as a new developer. So the real magic really here is this new operator. And so the most important thing to understand from this video is really these 4 steps. So make sure that you understand them, and then in the next video, we will work with prototypes and finally see the magic of prototype inheritance in action. Now it's time to finally start using prototypes.
So I'll be this dot first name is equals to first name, there you can see this dot second name, so second name.
And after this, you will feel like a real pro developer, believe me. And we're going to continue with the example from the previous video. Okay, but now we're going to talk about prototypes. So actually, we talked about prototypes, prototypal inheritance, and delegation earlier already. But how does all of that actually work? Well, it can be summarized like this. So first, each and every function in JavaScript automatically has a property called prototype. And that includes, of course, constructor functions. Now, every object that's created by a certain constructor function well, it can be summarized like this. So first, each and every function in JavaScript automatically has a property called prototype. And that includes, of course, constructor functions. Now, every object that's created by a certain constructor function will get access to all the methods and properties that we define on the constructor's prototype property. So just to visualize, in our case, this would be person dot prototype. So the prototype property of the constructor function. So again, as I was just saying, all the objects that are created through this constructor function here will inherit, so they will get access to all the methods and properties that are defined on this prototype property. And so let's now actually add a method to this prototype property. And so this is actually an object. And so we can now say calc h. And then we can simply set it to this same function here. So equal, and that's it. Now we get some error here, and that's because I misspelled prototype. So that's type right here. And let's actually take a look at this prototype property, just for curiosity. So that's not comma, of course, it's the dot. And so here is that prototype property. And so you see that right now we already have the calc_h method in there. So before it was kind of an empty object. So never mind these two here. So basically it was empty before, but now there is the calc_h method already in here. So this one that we just defined down here. All right. And once again, remember how I said that each object created by this constructor function will now get access to all the methods of this prototype property. And so, of course, also to calc_h. And so we should be able to do this. So Jonas, which is this object here, which was, of course, created by this constructor function. And so calc_h. And let's see. And indeed, we get the correct h here. So it worked. Great. That's amazing. So we can now use this method here on the Jonas object, even though it is not really on the object itself, right? So if we check out Jonas here, then you see that it contains, of course, the birth year and the first name, but it does not contain the calc_h method. But still, we have access to it because of prototypal inheritance. Okay? And of course, the same is going to work for Matilda here, and of course, also for the Jack object. Beautiful. So that effectively solves this problem that we had before when we added the calc_h method directly to each of the objects. Remember that? So here we would have created a copy of this method here and attached it to every single object. And so that's why we don't do this. Instead, what we do is this. Because now there exists only one copy of this function. So only one of them exists, but then all of the objects that are created using this constructor function can basically reuse this function on themselves. And so the this keyword, of course, in each of them is, as always, set to the object that is calling the method. And so here that's Jonas, and here that's going to be Matilda. So just like we learned previously, the this keyword is set to the object that is calling the method. Now right, so in a nutshell, this is how we implement very basic prototypal inheritance in JavaScript in practice. So we just observed that the Jonas and the Matilda objects are kind of somehow connected to the person, right? That's why they can have access to these methods, or in this case, to just this method that is located inside the prototype property of person. But how and why does this actually work? Well, it works because any object always has access to the methods and properties from its prototype. And the prototype of Jonas and Matilda is person.prototype. And we can actually confirm that because each object has a special property called __proto. So like this, __proto, and then again __. So this looks a bit weird, but this is just kind of how it works. So let's take a look. And so this is the prototype of Jonas. It's not the prototype property, but it is simply the prototype. Okay, and so here again, we see the calc_h function, and that's why Jonas is able to use this. So the prototype of the Jonas object is essentially the prototype property of the constructor function. So let's quickly see that as well. So we can check that. So person.prototype. And so this should now be true, and indeed it is. All right. Quickly see that as well. So we can check that. So person.prototype. And so this should now be true, and indeed it is. All right. But what I just said sounded incredibly confusing, didn't it? So shouldn't person.prototype be the prototype of person? I mean, should this prototype property here not be the prototype of person? Well, actually, no. So this is the confusing part. So person.prototype here is actually not the prototype of person. Prototype property here not be the prototype of person? Well, actually, no. So this is the confusing part. So person.prototype here is actually not the prototype of person, but instead it is what's going to be used as the prototype of all the objects that are created with the person constructor function. So that's a subtle but important difference that you need to keep in mind. And in fact, what I just said is confirmed by this comparison that we just did here. So we just saw that Jonas's prototype, which is this, is the prototype property of the person constructor function. And there are actually other built-in methods that we can use to prove this. So on any object, for example, object.prototype, we can test if this is a prototype of another object. So we can call is prototype. So is prototype like this of, and then Jonas. And so this should also become true, and indeed it is. So this confirms one more time that person.prototype is indeed the prototype of Jonas. And the same for Matilda, of course, as well. But person.prototype is not the prototype of person. So you see, it is false here. So this very common confusion comes from bad naming of this property. So the fact that it's called prototype kind of implies that this is the prototype of person. But as we just learned, it is actually not. Probably shouldn't be called prototype, but instead something like prototype of linked objects or something like this. So if this makes it easier, you can think of the prototype property as prototype of linked objects property, even though, of course, it's not called like this, but this would be a more honest name. So take some time to really understand what the prototype of what object actually is here. Now, anyway, where does this property here on the Jonas object actually come from? Well, remember the new operator that we talked about before? Well, it contains this step number 3, which links the empty new object to the prototype. And so basically, it is this step number 3 which will create this proto property. So it creates this proto property and it sets its value to the prototype property of the function that is being called. And so that's exactly what is written here, right? So again, it sets the proto property on the object to the prototype property of the constructor function. And so this is how JavaScript knows internally that the Jonas object is connected to person.prototype. And in fact, when we check out the Jonas object here, we can indeed also see that property in here. So it's also right here. And if we open that up, then you see exactly person.prototype, which contains this called h function. All right? So I'm spending a lot of time here for you to really understand what this proto property here is and what the prototype of the constructor is and how they're all linked, because this is one of the most important things and also one of the most difficult things to understand in JavaScript. But I hope that it's becoming increasingly clear, and there will also be a couple of diagrams in the next video that will basically bring all this knowledge together in an easier to understand way. So by now, you're probably sick of hearing the word prototype, but I just wanted to quickly show you that we can also set properties on the prototype, and so not just methods. So let's say person.prototype.species, and so this is something that all of the objects here will have in common, and so that's Homo sapiens. All right, and so if we now take a look at Jonas and at Matilda also, then we should see this property, so the species on both of them. And actually not directly here, but indeed they will be here in this prototype. And so we will be able to do Jonas.species and Matilda.species, and both of these objects will then inherit, so they will get access to this property from the prototype. So you see, in both cases we indeed get Homo sapiens. Now, however, since when we take a look at these objects, well, as we just saw, this property is not really directly in the object, so it's not its own property. So own properties are only the ones that are declared directly on the object itself, so not including the inherited properties. And actually in JavaScript, there is a way of checking for that. So we can do Jonas has own property, so that's with a capital P here. And so let's first check for first name. And indeed, this object does have its own property with this name, but now if we try species, then that is going to be false. And again, that's because this property is not really inside of the Jonas object. It simply has access to it because of its prototype. So because it's in the prototype property of person. So right here, right? And sometimes this method here can be quite helpful in certain situations. All right, and that is probably enough for one lecture. And as I just mentioned earlier, in the next video, I'm going to show you a nice diagram of all of this. So stay tuned for that one. Let's now consolidate the knowledge that we got over the last 2 videos in a nice diagram that brings everything together that we know so far. And everything starts with the person constructor function that we've been developing. Now, this constructor function has a prototype property, which is an object, and inside that object, we defined the called h method. And
As I was saying, someone mentioned it correctly. We should have done DOM before, but doesn't really matter. We can actually do DOM pehle bhi. Nahi hai. We have not yet learnt about Node.js backends, HTTP frameworks, Express. So this is a what's called a client. Hello, hello. How's everyone doing today? Name the variable correctly. Move this dot color equal to color from here. I can remove. Doing some asynchronous function call like you did before, right? When I wrote set timeout promisified, वहाँ set timeout लिखा हुआ था. When I'm writing fs read file promisified, in the end I'm calling fs.read file. and hence I think their priority sort of problematic, but I don't mind. That is what we'll do in the next class, which is async await syntax and writing your own promises. This or writing your own promises is the same thing. Writing your own async functional promises is the same thing.